Okay, so you're copying down those 5 series. Take a look at them and consider, they've all got dots at the end. So they go on forever. They're infinite series. If you wanted to find the sum of the infinite series, 1,000,000 terms, would that be something that you could do? So the first one, it's arithmetic. Those terms are getting bigger and bigger and bigger, each one of the terms. So when you're finding the sum, your sum is going to keep getting bigger depending on which term you're taking the sum of, right? So here, the sum is approaching infinity. Okay? So there isn't a sum of that geometric. Next one, that's not geometric, arithmetic. The next one's arithmetic as well. You keep subtracting, but think about that. If you keep, so the sum is adding all the terms together. Here, there's going to be a ton of negative terms if you're going to infinity. Well, that's just going to approach negative infinity as you keep adding the terms together. So it doesn't have a finite sum. We're looking for series that will add to a value, okay, an actual number. Next one, what is that? That's geometric. You keep multiplying by 2. Those term values are going to get really big, so that sum's going to approach infinity. The next one, that could be considered geometric or arithmetic. Geometric, you're multiplying by 1. Arithmetic, you're adding 0. In any case, it's never going to add to one particular value because you keep adding 3. Okay, you keep adding a number that's bigger than 1. So that goes to infinity. Next one, 1/2 plus 1/4 plus 1/8. So each term there, so this is a geometric. You're multiplying by 1/2 each time. Okay, so the term values are getting smaller now. Not negative smaller, just smaller actual values. So each time you're finding a sum, you're adding on a little bit smaller amount than the last time. Okay, so over time, as the term numbers go to infinity, so infinite number of terms, essentially at that end, at that infinity, you're basically adding 0. It's just a titch above 0, right? So it's getting closer and closer to adding 0, which means your sum is getting closer and closer to 1 value. This we say actually approaches what we call a limit L, or a particular value. Okay, so what's different about that than the previous 4? First of all, it's geometric, for sure. Okay, and comparing that to, say, this geometric, or even this one, that's an R value of 1. This is an R value of 2. This is an R value of 1/2. So having an R value less than 1 will be the criteria that tells you you can get the sum of an infinite geometric series. Okay, so let's see how this works. So for that particular series, if we find now, so this one here, S1, remember, is 1/2. Okay, it's the same as the first term. S2 is 1/2 plus 1/4, which is 3/4. Okay, which is, so as a decimal, 0.5, this is 0.75. S3 is S2 plus the next term, which is 1/8. So that's going to be 6/8 plus 1/8 is 7/8. And that's equal to what? 0.875? I think. Yep. Okay. So the sums are getting bigger but the gap between the sums, that's 0.25. This is 0.125. The gap between them is going to be smaller. Okay, so let's see. Question here. Isn't it always going to be less than 1? Barely. Barely? No, as long as r is less than 1, then it's an infinite geometric series that converges to one value. So it can be 1/10, and that's going to, so I'm not sure if that's what you're asking about, Howard. Okay, and then let's do one more. S4 would be 7/8 plus 1/16. So that's 14 plus 1 is 15/16. So you can see the numerator is always 1 away from the denominator, but as the denominator gets bigger, that means that that difference is getting smaller. So here, maybe that's what you meant, like the sum of this, Howard? Not sure. Yeah, maybe that's what you meant. In any case, as we keep adding the terms together, this is only 4 terms. If we keep going, you'll see that the sums approach the value of 1. Okay? Now what you can do here is think about our formula for the sum. So sum of n terms, remember, T1 times r to the n minus 1 over r minus 1. So if we put in what we know here, I'll give you a sec to get caught up before I do that. Okay, so now if we put in the values that we do know, so our first term was 1/2, our common ratio was 1/2. Okay, and if you simplify this, that's going to be 1/2 minus 1 is negative 1/2, right? So this will be negative 1/2. So those will divide out. So we'll get, here I didn't have medium. We get that expression, right? If you expand that out, that's 1 minus 1/2 to the n. Okay? Well, think about what happens to 1/2 as you raise it to the exponent n. So 1/2, let's say to the 4th, is 1/16. 1/2 to the 10th is 1 over, what's to the 10th? 1024. 1/2 to the 20th is 1 over, don't copy these down, just watch. Is that? So as n gets really big, that value of this gets really small. So essentially, this term here goes to 0, and you get 1. So what that's saying is, if your r value is less than 1, then that term will go to 0, and we don't even need to incorporate it into our formula. So now if we do S infinity, it's going to be negative T1 over, so if I put that in here, so this is this goes to 0. So I get t1 times negative 1 is negative t1 over r minus 1. That is the sum of an infinite geometric. Now we usually show it like this, t1 over 1 minus r. So we actually incorporate the negative in the denominator and switch the terms around. Okay, so that's more frequently how you will see that, and that's what will be on your formula sheet. So this is the sum of an infinite geometric series. Okay. And that's what we're going to use. Okay. Now, some words to be aware of. I think I used them before. So, a convergent series is an infinite geometric. Actually, it's not all, but for this semester it is. There are other convergent series, but for this course, that would be an infinite geometric series where r is less than 1 or greater than negative 1. Sometimes we'll show that as absolute value of r less than 1. So just be aware of that. It's another way of showing it. Okay. So the other opposite of that is divergent series. So for this course, that would be an infinite geometric where r is greater than or equal to 1, r is less than or equal to negative 1, or an arithmetic. Infinite arithmetic, sorry. Okay, those are called divergent. And you've used kind of words like that before in science or just in life. If you diverge, then you're going off on a different path, right? If you're talking about even walking with people. Okay, so let's do a couple of examples. Give me another minute or two to get caught up. Okay, question here. Okay, so things to look for. Is it geometric? If so, what's the common ratio? If the common ratio is between -1 and +1, then it's convergent, and you can find the sum. Okay, so find the R value for each of those. Notice how this one has decimals, so if you want to use decimals, you can. This one has fractions, so you need to use fractions. Okay, so 6 over 4 reduces, simplifies to 1.5 if we do use decimals. Okay, so 1.5, that means that we know 1.5 is greater than 1, so therefore divergent. Can't find the sum. So we're done. Take a look at the next one. Okay, negative 1/3 is between, so negative 1/3 is less than 1 and greater than negative 1. So therefore, it's convergent, and we can find the sum. So we need T1, actually I'll just write it underneath. So we have R, T1, and that's all you need. 36 over 1 minus R. If there's fractions in the series, then just make sure you don't use decimals in the sum. So this will be 36 over 1 plus 1/3 is 4/3. Actually, it works out to a nice number, 27.
Ms. McKay,
Yeah.
what does the 27 mean? Like, what does that mean in regards to whether it's convergent or divergent?
Well, it has to be convergent. That means that's the sum. If you add an infinite number of terms, right? So if you add 1,000,000 terms, it's going to be super close to 27. 1,000,000,000 terms, it's essentially going to be 27.
Oh, okay then. Thank you.
Okay, so for a geometric series, infinite series geometric to be convergent, then the common ratio has to be between -1 and +1. So we want to get the common ratio. So take the second term and divide by the first term. In this case, there's x's in them, so simplify. So that's going to be 2x over 3. Remember your rational expressions. So that means 2x over 3 has to be less than 1 and greater than -1. So we want to solve for x, okay? Because it says for what values of x. So Just like any inequality, we'll multiply everything by 3. And then divide everything by 2. Another way of saying that is absolute value of x has to be less than 3 over 2. Less than 3 over 2. So copy down this next question. Now we're kind of working backwards. We're told what the sum of an infinite geometric series is. We're told what the first term is. So you just have to solve for the common ratio. So sum is 20. First term is 16. We want to solve for r. We'll solve that equation. So r is 1/5. And it makes sense. If we're told that it's infinite geometric that converges to a certain sum, and has a sum, then we know the r value has to be less than 1. you're given three partial sums. So that just means you're given three particular sums, obviously not for infinite because they actually have term values there, or numbers of terms. So we want to find the sum of the entire series, and it's an infinite geometric series. The entire means infinity. So we want to find S infinity, T1 over 1 minus R. So we need to know the first term and the common ratio of this series. Well, remember, we talked about this yesterday. S1 is equal to T1. So in this case, T1 is 10, because S1 is 10. So we know this part. Now we have to find out what R is. For R, we need to know the term values. So S2, remember, that's going to be term 1 plus term 2. Well, we know term 1 is 10, and so we have to add term 2 to it to get 15. That means term 2 is 5. Okay, so from that, our common ratio will be 5 over 10, which is 1/2. If you wanted to check, then I would find T3. So therefore, T3 would be 5 over 2. T2 times 1/2 is 5 over 2. And then if we add 5 over 2 plus our S2, so S3 is T1 plus T2 plus T3, or S2 plus T3. You can do it either way. So 15 plus 5 over 2 is 35 over 2. Okay, so this is just a check. You do not have to do that. Once you found, you're told it's geometric, so once you found first and second term, you can find your common ratio. If the ratio was going to change, it wouldn't be geometric. So you've already been given part of that information. You don't have to check all the terms. So now our common ratio is 1/2. So that would be 10 over 1 minus 1/2 is 1/2. So that would be 20. And last one is, what was that, 4 or 5, is an application question. The super ball again, so a different super ball. So a couple minutes to copy that down. Okay, so super ball question. Again, I'm going to draw a diagram to help. Okay, so super ball is dropped. goes down, back up 75%, down. In this case, it keeps on going forever until it basically ends up going nothing, right? So this is 20. So the ball rebounds 75% of its previous height. So that means this height here, right? That would be 15, right? Because that's 75%. If the ball, so this is 15 here if you want to label that. If the ball keeps bouncing, determine the total vertical distance that the ball traveled. So remember, it goes down 20, then up 15, down 15. Up whatever 75% of 15 is, down. So there's 2 of each of these heights. So when I find the total height, or total vertical distance traveled, it's going to be equal to, I'll put this underneath, equal to the 20. I'm going to split it up, the 20 alone, because there's only one of them, plus this series of 15, and then 75% of 15, 75% of that again, twice. Once for going up and once for going down. So 2 times the sum of that series, and in this case, it's an infinite series. Okay? It just keeps getting smaller and smaller and smaller. Okay, in reality, without friction and gravity, it would just, well, maybe it wouldn't be 75% in that case, but it would get, it would still keep bouncing forever. Okay, so what's our infinite sum? So we've already taken care of the 20, so we're just looking at this. So the first term of that is 15. 1 minus the common ratio, you keep multiplying by 75%, which is 0.75. Okay. So, any questions on that? If you want to use 20 as your first term, you can. But then you're going to have to, so if you said total vertical distance, and you used 2 times S infinity, where you started with 20, that means you've counted 2 times 20. So you've counted this in, so then you would have to subtract 20. So you, by saying 2 times the sum starting with 20, then you've counted both the up and the down. But that ball started at the top, it didn't start at the bottom. So you would then have to subtract 20. So if we did it this way, we get 40 over, oops, that should be 0.75, over 0.25, which is 160, minus 20, which is 140. So you can do that. You just have to make sure you subtract 20 at the end.